All right, so today we're going to be solving logarithmic equations, which basically just means equations that have logs in them. So if you look, for example, here at problem 1, we have the log of 5x equals the log of 2x plus 9. Now notice how both of these logs are logs base 10. Well, if the logs are the same, that means that the piece that's inside of them must also be equal. So in this case, because these are both log of something, I can ignore the logs and just work with the inside pieces. 5x equals 2x plus 9. Well, now I can solve that equation like normal. So I just subtract the 2x over to the other side, which gives me that 3x equals 9. And then I can finish the solve by just simply dividing by 3 on both sides, which will give me that x equals 9 divided by 3, which is 3. All right, well, if you look at problem 3, it's going to be a little more complicated because we have a log base 7 on one side, but not on the other. So I need to get rid of that log so that I can get to the negative 2r that's inside of it. Well, to do that, notice that this log has a base of 7. Which means 7 is the number that gets rid of the log. Now, since we use a log to find an exponent, we can get rid of a log by turning it into an exponent. So I'm going to make both sides of this equation an exponent on the number 7. So this becomes 7 to the log base 7 power and 7 to the third power. 7 and log base 7 will cancel, leaving me with negative 2r equals, on the other side of the equation, I now have 7 to the third power. Now, I'm not sure what 7 to the third power is, but my calculator knows. If you have a calculator, you can go ahead and type it in. But if you don't, I'm just going to use this calculator that's right here on Google. So into Google, I'm going to type 7 to the third power. And Google tells me that it is 343. So I know that negative 2r is equal to 343. Well, I want the r alone, so I'm going to divide on both sides by negative 2. 343 will not divide nicely by 2, so you can turn it into a decimal if you would like, but I'm going to leave my answer as the fraction 343 over negative 2, which will be my final answer. Now, keeping that in mind, let's go ahead and look at problem 7, which says 12 minus 3 log base 5 of 2x plus 15 equals 21. Now, to solve this equation, I need to get this log alone first, which means I'm going to start by subtracting the 12 over to the other side. That will give me that negative 3 times the log base 5 of 2x plus 15 is equal to 21 minus 12, which I'm getting is 9. Now I still need my log to be alone, which means the negative 3 in front of it has to go. So I'm going to divide on both sides by negative 3. That will give me that the log base 5 of 2x plus 15 is equal to 9 divided by 3, which is negative 3. Now I want to get rid of the log so that I can get to the 2x plus 15 that's inside of it. Remember, we can get rid of a log by turning it into an exponent. In this case, it's going to be an exponent on the number 5. So this becomes 5 to the log base 5 power and 5 to the negative third power. My 5 and my log base 5 will cancel, leaving me with 2x plus 15 equals 5 to the negative third power. Well, if I type in 5 to the negative third power, my calculator will tell me that it's either a decimal or I know that as a fraction it's 1 over 125. So this becomes 2x plus 15 equals 1 over 125. Now I can go ahead and solve the equation just like I would normally solve. So I'll subtract the 15 over to the other side, which gives me that 2x equals 1 over 125 minus 15, I'm not sure what that is, so I'm just going to type it in my calculator. 1 over 125 minus 15, which is negative 14.992. So negative 14.992. Now I can divide on both sides by 2, which gives me that x equals, if I divide that by 2, negative 7.496. So I get that x equals negative 7.496. And this will be my final answer on problem 7. Last but not least, would you please look down here at problem number 12. So on problem 12, I notice that this time I'm adding the logs together. Now, remember back to when we talked about the properties of logs. When we add logarithms, we can condense that down to a single log by turning the addition into multiplication. So this log of x plus log of 7 becomes the log of x times 7. And that's going to equal the log of 37. Well, now I notice that both sides have the logarithm, so I can ignore the log and just work with the piece that's inside. So I have x times 7, which I'm going to write as 7x, equals 37. Well, now I can solve that equation by just dividing on both sides by 7. And since 37 over 7 is a fraction that won't simplify, I'm going to leave my answer as 37 over 7, and that will be my final answer here on problem 12. Go ahead and try this assignment out on your own and see how you do.